Hi, Mick McQuaid here with lecture 01b of iste422 Application Development Practices for fall of 2015. And in this lecture, I'd like to speak briefly about baseline setting. I'll stick to the lecture notes for the most part here, and I will point out that if you view the lecture notes in a PDF viewer, you have the potential to have a table of contents appear. In this case, it's called the table of contents. Sometimes it's called the bookmarks or something else. And you can see that there are 4 parts to what I'm going to talk about baseline setting. Now, the key thing to remember is that everyone follows a different path to this stage in education, even though you've taken a lot of the same prerequisites. And so this complicates the problem of setting expectations. Some people have learned to do some tasks, other people have learned to do different tasks. So I drew a task from a Hacker News challenge that should exercise some skills that you should be able to bring to bear on a lot of daily tasks. And to prepare for this exercise, we will familiarize ourselves with the software listed in the appendix to these lecture notes. You can see software is the very last item in the appendix. And there are many tools replicating the capabilities of the tools that we'll use, but these have been chosen to cover most of the basic concepts. And please do not ask to use different software for this exercise. I have permitted that in the past with dismal consequences, and if you ask, I can tell you plenty of dismal stories about those consequences. But suffice it to say that there will be plenty of opportunities for you to use other tools that you prefer later on in this course and elsewhere. So let's take a look at a few tools, or actually a little bit more than a few. So first is the text editor. So we will use a text editor called Vim, which is popular among software developers and which contains the features that are needed, or we can add the features that are needed. And we'll use tutorials that are available online better than anything that I or any general purpose individual could come up with. But we do need to review a few general ideas here in this document. So this is not the tutorial, this is a lecture about some of the ideas connected to some of the tools that we'll cover, and a partial list of the tools that we'll cover. So first, consider the fact that when this editor was developed in the 1970s, computers were very slow and displays had just entered common use. Most of the editing tools that existed when this editor was first produced were editors such as ed the editor and ex the extended editor that were designed to help programmers working at what we would call hard copy terminals. So these were basically printers connected to keyboards. And I suppose I could actually Google that if you want to picture it. You probably have not seen one unless you've been to the Computer Museum in San Francisco. I have lots of pictures that I've taken both at that museum. Oh, there was one right there. Well, here's one right here. So it's essentially a keyboard with a printer attached to it. And you can use the keyboard to type things into the computer, and then you can use this printer to print out bits and pieces of what you've typed in so that you can get an idea of what's in the computer. So this is a very, very difficult way to work. So you had to have a very clear mental picture of what was going on because there were almost no visual aids. Typing stuff and having it print out like that was a very poor visual aid. So if you imagine typing your program into a computer where you have no display at all, that should sound like a very painful activity requiring a lot of concentration and the construction and maintenance of a clear mental picture. And it may seem counterintuitive to use tools designed for such a primitive environment. And the purpose, in part, is to encourage you to form a mental picture. But there is actually more to it than that, and we'll discuss some of the issues later. But for now, you should simply understand that the concept of the editor functioning in a highly constrained environment is what we're going for, where the programmer's mind is supplying quite a bit of the information that today would be provided by graphical supports. So some of the concepts for this editor that apply to all programmers' editor are as follows, and what I've highlighted here in italics are concepts. What I've highlighted in blue and a typewriter style typeface or a fixed width typeface are actual commands that can be issued in Vim. or directives that can be issued in Vim. So split is one. So a programmer's text editor must have many ways to split windows so that you can view another file than the one that you're typing into, or another part of the same file that you're typing into while you're typing into it. There's a basic split command in Vim, and then there are also many parameters that it can be given in many ways to bind it to shortcut keys to fit your habits. In addition to a split that draws a horizontal line across the window, an editor needs a way to split the window the other way, drawing a vertical line down the middle. And you can actually see this, for example, here. Let's take a look. I'm just going to grab a copy of this file as well as some others here. So here's a window, a text editing window I happen to have open in Vim in another part of my display. And here's the kind of split that's generated by the split command. So there's something above and something below. And over here we see the kind of split that's generated by the vsplit command. So there's something on the left and something on the right. And in fact, I guess this, let me just take a look here. Yeah, this file right here is actually the source file of the file that we're looking at in the PDF document. This is a file listing and some scheduling material in other files. It's not important what's there. I'm just trying to give you the idea of splitting windows there. Now, in addition to splitting windows, we would just like to, in general, hide some things. We want to be able to hide some of the text, for example, to show the structure of a file. And in fact, that was being done here. So in fact, I'm just going to hide more of the text here so that, oh, okay, actually, no, this does, so all of the headings are displayed here, and we can see how many lines are beneath each heading. And we can see how many lines are beneath the introduction heading here. And all that's being displayed is what I was writing here about baseline setting before. So we need to be able to do this kind of hiding, and we use this term. This is used not just in Vim, but throughout programmers' editors. Folding uses the metaphor of a piece of paper, so that you fold up the piece of paper so that you only show method headers, for example, if you're programming. And you also want folding to understand the syntax of the language. So for example, what I just showed you is written in Markdown. So the basic folding commands recognize this and automatically fold it according to the Markdown headline syntax. All text editors have search functions, and one for a programmer needs to have extensive support for regular expressions, both for searching and replacing text. And the regular expressions should support greater flexibility than mere literal text. So we shouldn't just necessarily be able to find all occurrences of the word mere and replace them with the word only. For instance, it should support patterns in both the search and in the replacement string, so that we may actually replace with different strings that we don't necessarily type in directly. We type in patterns and we get replacement patterns. And these kinds of searches should be able to work on individual lines, ranges of lines, an entire file, or actually across many files. Now, in addition to the use of regular expression for search and replace, we also might want to do other actions than just replacing text. So it should be possible to perform some specified action on every line that matches a pattern. And this is done with the Vim global command. So I might, for example, want to delete every line that begins with that has a certain pattern in it, or I may want to change the capitalization of every line. Things that are not simply replacing text. I may want to gather them and create something else out of them. I don't know. Anyway, syntax highlighting. So a text editor should offer flexible syntax highlighting that you can customize. So there are actually some syntax highlighting schemes like Solarized, and we can just Google Solarized here. Let's just Google Solarized. So this is a scheme that transcends, it's available for Vim, but it's also available for many, many text editors. And you can see roughly what it looks like. This is the dark version and the light version. The dark version is what I just showed you a second ago, and here's the light version. And so these kinds of popular syntax highlighting schemes that have been studied or are the result of studies. You know, people do studies on programmers to find out what makes them effective. And so there are many such things that are well studied, well developed, and available for lots of text editors and terminal windows. Next, there should be a way to represent files in hexadecimal format for specialized editing tasks. And there is not such a feature specifically built into Vim, but it can be added easily. And in fact, for practically any commonly used facility not built into Vim, you should be able to search for an extension. You should be able to find an extension. And the same thing is true of the other major programmers' editors. If you're taking a database course, you may want to use the dbxt extension, for example, to support writing statements and passing them to MySQL or whatever database management system you're using. Most popular interpreted languages have extensions for Vim to support passing fragments of text in a file to an interpreter, which simplifies the task that we'll talk about later of keeping an audit trail of activities. That's a really big issue, keeping an audit trail of your activities. And the most basic utility for identifying differences between files is the utility diff, which is available on all platforms in all kinds of ways. Let's just search for diff here. And it's kind of a ubiquitous thing. And there are many different front ends for diff. So there are all kinds of graphical front ends for diff. Okay, it's also an abbreviation for differentials of combustion engines. So anyway, Vim has a version that basically just brings in the code of the standard diff utility so that it's easy to learn and use if you have used the standard diff utility. Compatibility with diff is common with built-in diff utilities in different environments. We'll do some exercises using a terminal interface. In fact, we'll do a lot of exercises using a terminal interface. And we'll introduce about 50 utilities. I'm not satisfied with the amount of terminal experience routinely given in this educational program. So I'm going to go pretty heavy on this. And these will be much easier to use. These 50 or so utilities will be much easier to use if we first learn to use a utility like tmux. There's another utility called screen that is similar, and some others that are somewhat similar. And what these utilities support are a couple of basic functions that are really important, plus all kinds of other interesting functions. And these two basic functions are window management and window detachment and reattachment. So first, let me briefly say that window management includes things like splitting terminal windows, resizing and rearranging windows, copying and pasting between windows, and receiving notifications between windows. Detachment and reattachment refer to the frequent need to close a terminal window without stopping the work in it, and then reopening that window later, possibly while sitting at a different computer, possibly in a different building, possibly in a different city. So for example, suppose you begin your work in a school computer lab, but you take a break to go home and eat dinner. And perhaps you have network access at home and you'd like to continue your work there, possibly staying up all night and coding like a maniac, possibly fueled by shocking amounts of espresso. This activity is made possible by a combination of youth, I'll admit, and a utility like tmux. Now the main program that is used in each terminal window is called a shell. And I'm not sure whether the idea that the operating system has a delicate kernel and that the shell protects it from clumsy users, or the idea that the shell protects delicate users from a barbaric kernel. That's a misprint there. It should say a barbaric kernel, not a barbaric shell. Or whether there is some other reason for this naming scheme. Suffice it to say that you work with a shell and the shell works with the operating system. And there are many shells available. And we're going to use in this bash, which is one of the most popular shells. And for the most part, all bash does is processes commands to run the 50 or so utilities that we will experience. And two of the most important features that we will learn are the use of bash to maintain an audit trail of activities. So we will be able to tell what we did before and possibly refine it and automate it. And the use of bash to link utilities together to perform more complicated tasks than any utility could perform alone. And this is very important. The second one is very important. The approach of linking small tools together to do large jobs reflects the basic Unix attitude. This is one of the most prevalent notions in Unix, which is that small tools can be better debugged and refined than large tools. Therefore, for one-off tasks, we should create a temporary infrastructure of small tools rather than relying on a single large tool. Many of the small utilities we shall work with have been available as source code for up to about 40 years, believe it or not, and they have as a result been very extensively debugged. By contrast, large tools like Video Studio or something come into fashion and fall out quite rapidly and are usually completely opaque. The code base for large tools may be completely replaced between versions without the end user being aware of it. And think about the kind of environment in which large tools work best. And I expect that you will conclude that they work best for complicated jobs that will be repeated vastly many times so that the issues will be easy to identify. But they will not help for small jobs that differ from day to day, where there won't be a lot of repetition of exactly the same action, allowing you to easily uncover problems and issues. Now, instead of working with a shell, you can also call libraries directly from your program. So, and for many shell utilities, of the 50 or so shell utilities that we will work with, there is a corresponding library, and working with the shell is for off-the-cuff, informal, one-off activities, whereas including the library in your program is for highly repetitious activities. In fact, a common path of development is that you begin doing something informally and you develop a temporary infrastructure for it. You find yourself reusing that infrastructure. You reuse that infrastructure enough that you realize that it's worth building a system to do. And so what started out as a way of easing your pain on a day-to-day basis becomes a for sale tool. Okay, so that's the end of baseline setting. Most of baseline setting really is about the exercises that we'll do to familiarize ourselves with these things. These have just been a few general concepts that we need in order to get going. Thanks for listening.